We present action slot, visual action-centric representations, for multi-label atomic activity recognition in traffic scenes. Atomic activity introduces a description to ground the road topology in action. An intersection can be decomposed into 4 roadways and 4 corners. Then, one can describe the motion by defining the movement on the road topology, for any specific agent from a short clip. For example, a car turning left from Z4 to Z3 is denoted as Z4 to Z3 C label, and a group of pedestrian crossing from C2 to C1 is labeled as C2 to C1 P plus label. Such combination of topology-grounded action and types of road user can compose 64 classes, and can be formulated as a multi-label action recognition task. We study the existing action recognition models, video-level representations, and object-aware representations. We argue that the video-level representation are not discriminative to predict multiple activities with pooled features. And object-aware representations, following the detect and classify paradigm, are prone to fail as the detection is not perfect, and difficult to be fused with context. Moreover, not all road users are involved in an activity. In this work, our goal is to learn action-centric representations that are discriminative for each class of atomic activity, can proactively capture actions, by encompassing both motion and context information. Motivated by the recent success of slot attention on discovering concept, we repurpose slot attention to model atomic activity and learn action-centric representations. The original slot attention is used for object-centric representations where each slot features is trained to represent as an arbitrary object. The difference between slot attention and conventional cross attention is within the competition mechanism. The softmax in slot attention is applied in the query axis instead of token axis. In this way, the competition can force each slot to pay attention to different regions. Our model takes spatial temporal features as input. Next, we initialize action slots, and allocate each of them to predict a specific activity class, which is different from the original slot attention where slots are assigned to an arbitrary object. We further introduce an extra background slot that does not allocate it to any class of activity, so that it can occupy regions where are not relevant to any activity, and the competition mechanism will force the action slots to discover atomic activities from the remaining regions. Finally, we use action slots features to predict the corresponding labels. To facilitate the learning of background slot, we provide background mask to supervise the attention of background slot, where the mask includes sidewalk, building, sky, and vegetation. We also propose a regularization loss, to force those action slots allocated to negative labels not to pay attention to any region. For example, the yellow Z3 to Z4C label is negative in the illustration. In this way, the other action slots are easier to find the regions related to the activities. Moreover, we investigate the atomic activity dataset, OATS, and found that the imbalanced class distribution can hinder the effectiveness of evaluation, as nearly half of possible classes are absent. To address this, we propose a new dataset TACO, by collecting data in the Carla simulator, which enables a more efficient collection of balanced distribution of activities. We evaluate action slot on 3 different datasets, including OATS, the proposed TACO, and new scenes. The action slot outperforms all evaluated video-level representations and object-aware representations. The results verify our arguments on video-level and object-aware representations. In addition, we re-implement existing video slot attention methods to compare with action slot, verifying that the prior slot attention works are not suitable for atomic activity recognition. We ablet all the proposed design and verify the effectiveness of the background slot and the supervision. We compare the action slot with the one uses object masks as guidance. We evaluate them on scenarios with different numbers of road users present in a video, and demonstrate the effectiveness of the background supervision. We apply action slot on various backbones, and all of them are improved by a large margin, showing strong generalization. We visualize the attention mask from action slot, and demonstrate that the action slot can learn action-centric representations even in complex scenes and occluded scenarios, where the road and corner are covered by the traffic cones and construction. We found that action slot can successfully recognize activities in these challenging scenarios. More interesting, we found that action slot can capture the transition of 2 successive actions performed by an agent. Thank you for your attention. Please check more details on our website.